We start again. So thank you for being back here. We have the first contributed paper of the conference by Arno Simons. It's titled The Size Project, Makes Contextualized Word Embeddings. And Arno has a background in a history of philosophy and sociology of science. And he worked in interdisciplinarity, right, for his PhD. And now he has a postdoc in ERC funded project on, I see, network epistemology in practice. So thank you, Arno, for being here, and the floor is yours.
Thank you very much. Okay, so today I talk about the mixture or the merging or the coming together of the styles project and contextualized word embeddings. And thanks go to my colleagues Adrian Wüthrich, who's also the project leader of the ERC project, and Michael Zichert. Oh, no, okay. Yeah, great. Okay, so the styles in science is a broad concept, and I'm explicitly using it here in a broad sense. I'm mostly drawing from Ludwig Fleck, who wrote the book in the 1935, just 1 year after Popper's book. So it's really, I find it always impressive how at that time somebody would say these things. And also on Ian Hacking, of course. So styles are ways of thinking and doing. That's Hacking's formulation. They are collectively and dynamically stabilized. So they are a product of the doings of several people and always dynamically, temporally stabilized. And they, on the other hand, they guide the perception and the meaning and the doing and so on of the individual. So that's why I put this little arrow to kind of indicate this dialectics between, it's basically a structure agency kind of dialectic. So you have the styles influencing the individuals, influencing the styles. And then it's self-authenticating. That's Hacking's formulation, but Fleck uses some similar thing. And the idea being that there's no epistemologically truth outside of styles. This would be a hard argument claim, but if it's softer, you could argue also that there are interlapping, overlapping styles, and that these type of authenticating mechanisms work between styles. The point I want to make here is that while styles are materialized in several aspects in material, social, epistemology, etc., they are highly mediated and through language and text, and this is what the contextualized word embedding is focused on. So if you ask how many styles are there, Hacking might say 6, or I don't know what its number is, and Fleck and other people might say if we just use it as a analytical lens, we can identify styles at several levels and we can overlap them, and that's more the broad sense that I have in mind here. And there are obvious links to the sociology of knowledge, to discourse analysis, Foucauldian type of discourse analysis. Hacking comes from Foucauldian background, and Gestalt psychology also, Fleck also comes from this background. So these are my two heroes here. So styles, text, and meaning, that's my focus here. So I've just brought you 3 quotes. One is by Fleck, that the thought style may also be accompanied by a technical and literary style characteristic of the given system of knowledge. So you see the style as a style of language and the system of knowledge. And Hacking would say, each new style brings with it new sentences, things that were never said before. But he rejects, says he, any uniform all-purpose semantics, that is one lesson to draw from Wittgenstein's talk of different language games. And then something I want to underline here, and it comes to it back later, is that Ludwig Fleck says that words as such do not have fixed meanings. They acquire their most proper sense only in some context or field of thought. I'm not sure how he meant the or, but I will use it in a way of both. It's 2 different things actually, and the models that I will present you can make the difference between these 2, between context and field of thought. You will see what I mean. Just to situate this, if we think that studying styles and context has been mostly done by close reading analysis, type of analysis like discourse analysis, interpretive analysis, objective hermeneutics, whatever you call these things, and then there are attempts to do it with distant readings, We've seen several before, so citation type of analysis or term co-occurrence covert analysis. Colomb was mentioned before, but now there's this new thing, new kid on the block, contextualized word embedding. And that's what I want to present to you now. So first of all, what can we do with this? One thing is that we can measure or detect and so on semantic relations between concepts. And we can detect the meaning of concepts in context. Again, I'll show you what I mean. And then we can, because we can do that, we can differentiate between dominant and subordinate senses of a concept. Concept can have several senses at the same time. And then we can, and that's the second type here, the meaning of concepts within a semantic space. There are then downstream applications like topic modeling, text classification that we could improve and we can improve with these type of contextualized word embeddings. So there were static word embeddings. You may have heard of them, like word2vec, etc. I think Luca later will present something. He might, if it's the same thing I know, present something with word2vec. And in word2vec, each word has a embedding, meaning there's a semantic space. Don't bother, it doesn't matter now where it comes from, there's a space. And then we have words like these four, and they are points in this vector space. And this is a high dimensional space. Here it's only 3 for visualization purposes. And then these words have their fixed meanings within this space. And then you can measure distances and you can calculate all sorts of things that you can do with vectors. You can do vector calculation stuff, and then you can calculate meaning. That's the idea. And then came the idea, how can we do contextualized word embeddings instead of static ones? And the model mostly used, or the architecture is the neural network architecture mostly used for this, is called BERT, bidirectional embeddings. What is it? I'm too nervous right now to remember. Doesn't matter, that's the paper. It's a Google team that came up with this. And it's interesting because they used a training objective for their architecture, which goes back to Gestalt psychology. Is a guy named Wilson Taylor. He proposed a close procedure. So it goes like this: we mask one word, and then the people have to guess what's behind the mask. You don't see it, so you will look at the context, either at the whole paragraph, or maybe you will focus on specific. You will put your attention on specific of these, like this maybe, and then you say, okay, that's the plank in this context. And then there's maybe another local context within this, again, local context, where you say, okay, this is another type of plank maybe. And then the idea is that we shift these words. Instead of like the plank, look at the plank in the middle, it will go into 3 planks, let's say, that have different meanings, contextualized meanings with these other words. And so we can have all the planks that we find in our text that we analyze have slightly different positions in the vector space. And now we can do lots of tricks. We can do clustering, and the clusters can then be taking the vector mean, they can be averaged, and then the average might be taken as a cluster prototype. So it's like, what's the meaning of that type of cluster? And this could be a specific sense, like the Planck in the context of the Max Planck Society, or the Max Planck constant, or the Max Planck satellite. Similar thing, you can do the whole thing. You can just do the average meaning of the word. That's basically similar to word2vec, what it does. And you can do whatever. You can do field type prototypes. I do it with astrophysics and high energy physics, or you can do time slice prototypes like 1977 or whatever the data is. And there are these 2 types of context that I want to emphasize. So one is the context of the occurrence inside of the text, where does the word occur? And the other is the context in terms of the trained semantic space. And so if you have a BERT model that you download from Google, they have pre-trained it on Wikipedia, for example, then that's your semantic space. So I took the Wikipedia one, trained on Wikipedia, and trained it again on 600,000 articles from archive from high energy physics and astrophysics, and that's what I used. So that's just a quick overview of the it's 110 million parameters. That's the model. It's considered small in today's context. but it's the good thing about it. It's actually open source and it's doable. So I trained this model on a single MacBook Pro with M2 chip and 96 gigabyte of RAM, but still, you can do it. You can also use it. You can use some clusters or whatever to calculate it, but it's doable. In contrast to GPT-4, you could never do that. Okay, so I'm very fast actually. I can slow down my pace. Oops. So what we do, or I do in this project, and we discuss it together, and Misha does similar things with another type of corpus. So I told you I have 600,000 articles from the archive. They were either from astrophysics or from high energy physics. And I downloaded these articles, I cleaned them, blah, 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 and I chunked them into, I think, 22 million paragraphs. I fed this to the model, and now we can use this semantic space, which is one type of context of high energy physics and astrophysics combined, to then look at the language and the text used by high energy physics and astrophysics. And the corpus that I'm analyzing is the same that I trained it on. And so one thing we did is, because I don't have a background in physics, Adrian has, the project leader here, and my colleague, and we looked at like history, philosophy, sociology of science analysis of comparisons between high energy physics and astrophysics. And there are lots of debates, for example, about the meaning of such conceptual terms like experiment or observation. In what sense is there sometimes maybe they're different, sometimes they might be similar. Some people argue, for example, that because astrophysics can only see the world through telescopes, etc., and high energy physics does a lot of these accelerator experiments, that this is a very different thing. But others argue some type of observations, or people in astrophysics might think of observations more in terms of experiments, because they are also very highly structured with satellites or with like neutrino detection chambers, etc. So there are these types of debates. There are debates about direct versus indirect observation or access to the world, about the status of simulations in the trias of experiment, observation, simulation. What is a simulation? Is it an experiment? Is it an observation? Is it theory? Is it a model? What is it? And then there's of course now, as someone asked it earlier about AI, has it changed science? Of course it has, and the physics, of course it has changed the physics community. So deep learning has taken off, and everyone talks about it. So what does it mean? What does it mean in physics? I mean, everyone talks about AI, so obviously they do it too. And so I just one slide, because I didn't want to bombard you with more of these, and also because of I think here's more the interesting thing of what can we do with this model, and also its preliminary results. But this is to give you an idea. So you see on the left side the archive. It's just one example of the observation or the detection of the Higgs boson at the Atlas detector, and you see that I took 600,000 of these, or it should be preprints, not preprints. And I chunked them into these paragraphs. I fed the paragraphs to the BERT model, and you can actually use my model if you want from Hugging Face. It's the platform where all these language models are released, if they are released. And so in a sense, the BERT that I use and trained it with this stuff on top is kind of now a bit more physics knowledgeable. That's the idea. Okay, and now one thing you can see, because I looked at things like deep, because of deep learning, I looked at lots of words that are related to these concepts, and in the question of the deep learning thing, I looked at the word deep, but you can see it's very similar with network, and also with machine and these type of words. So you find I clustered these words. So over time, the lines. So the black line. I don't know if you can read this. You probably cannot. Okay. So the black line, or let's say first, it's the green here. It doesn't really matter that much, but I think this green line, you see it green, that's the overall corpus growth. It's just an idea of how the corpus in general grows. And this one is how the word deep, all the words deep, like just the average meaning of deep grows. And then here you have the different clusters. I tried different clustering solutions. I used k-means clustering algorithm, and I found a solution that is sensible from a domain expert type of perspective. And I think here I found 1, 2, 3, 4, 5 clusters, and these are the colors. And you can see how the numbers, like the intensity or frequency of the clusters, grows over time. And there's one that starts just after. That's a line I drew because some people in the literature say that 2014 was when deep learning took off in physics. So just right after that, and 1 year later or so, it goes up. And to identify what the clusters mean, I did thank you. I did just a very plain frequency analysis of the top words surrounding the occurrence of the word deep. And here you find the top words is of course always, it's not of course, but it's deep is always the first because it's deep. And then there's learn, network, neural, model, method. And the other ones are other types of, I have to see it actually here, other types of deeps in physics. For example, deep image survey, observe galaxy field. So there's the deep field, that deep field photography, for example. There is stuff like Hubble field survey, ultra stuff. There is deep inelastic scattering. It's also a way of using deep in physics. So you can actually see that this type of method can detect these meanings that we also find meaningful. And it's by looking only at the word deep, right? This is, you have to understand, it's not a topic model or anything like that. It's really just by looking at the word deep. And there's another thing that we find very interesting because there's this idea, or there was this hypothesis that experimentation or that observation in astrophysics is similar to what high energy physics people might mean with experiment. And what we actually find, we have to look into it deeper because it's, even for me, it's very surprising to find this, but that these are, if you just look at the 4 blocks there, so this is experiment in astrophysics and in high energy physics, and this is observation in astrophysics and high energy physics. So you see that the astrophysics observation is closer or has a similarity of 5.4 whatever to the experiment meaning in either high energy or astrophysics. But if you look at the high energy physics meaning of observation, it's quite different from experiment. So this is something I find super surprising, interesting, and it just shows us how, or what type of avenues actually opened by this new method. Yes. So to wrap up, I think that there are several links, interesting links between contextualized word embeddings and styles. One is the obvious one, it's a new tool that we might use. And we have to be careful, of course, and we have to see and understand how we can use it. But on the other hand, it might even be more than just a tool. It might be something like a model or something of a style, because I mean, it's a model for, it's a language model, it's called language model. And to the extent that styles, the theory of styles has also this idea of that words mean things within styles and within context, I think it can help us even to improve the theory or to understand the theory. That's at least something I hope. And I told you that I think there are 2 different meanings of concepts here, of context. One is that the words within the text itself can have different meanings, like on top or on the bottom or whatever. But also the other type of context is the training space or the semantic space that I have trained. And this is why it's different if I use a Google model that is only trained on Wikipedia versus a model that is also domain adapted to physics language. And then there is, I just want to point out that there's a rapidly evolving studies of evaluating these type of tools, and this is really continuing, and people try to understand which layers of the model can we use for to extract the embeddings and what does it mean and how is the space structured and etc. So there's ongoing stuff. If you want to use these things, you have to really be up to date. The models also changed. So far, BERT type of architecture is still dominant in all of these type of analysis. And then, yeah, there's the open question of how can we link this new method to other methods in scientometrics. For example, topic modeling, there's BERT topic. I discussed it with Luca earlier, or there's citation analysis. And I mean, in my understanding, citations are also just, not just, but they are words in text, basically. And so they also have meaning, and we could think of all sorts of ways of how to use, combine these things. Thank you very much.
Thank you very much. Perfectly on time. Even 10 seconds in advance. So, questions? Right?
On the end, Brad.
Yeah, I know. I'm an irresponsible audience. Thanks. So just, I know you're pressed for time, so I'm just curious what work the styles in science notion is doing. And if I remember correctly, I think hacking, his inspiration was from, is it Crombie, the historian? Yeah. So that can, putting Fleck and hacking together seems curious, I guess. And even though I think hacking was obviously a sympathetic reader of Fleck. So if you could just speak to that, or maybe it's the project grew out of this styles of reasoning, styles of science or styles of reasoning literature, but you've parted companies with it. So if you could speak to that. Oh, yeah, sorry.
Yeah, thank you very much for the question. You're absolutely right that hacking takes the styles, a lot of it from Crombie, because Crombie, I think he defined 6 styles or so, and hacking too, I think 6 or maybe added, I don't remember exactly. But also later, like there's a paper that I also quoted, which is something like 30 years of style project, what have I thought so far or whatever type of paper. And there he writes that he clearly positions himself in the tradition of Ludwig Fleck. He says that this is basically the one who came up with this idea. And also he says that, I mean, or he wants to, I think he still might want to use the word predominantly to describe these 6 types, or to say that these are like some clusters that are interesting. Whereas Fleck allows for much broader use of it. It's similar to, I wrote in my master's degree, I wrote this thesis, or not a thesis, a homework on Fleck versus Kuhn. And it is very interesting too, because Kuhn uses, I mean, he mentions Fleck in the preface, but he doesn't say anything in the rest of the book. And he is, in my reading, he's kind of using Fleck in a binary kind of way. It's always like either there is something or it's not, or it's, it's 2 things they're completely separated, but it's not like Fleck allows for more gradients. So it's the same with styles. You can think of styles within a community, within a research group, and you can go up and down. And I like this broader notion more. Yeah. That's where I come from.
Just the follow, like, what's the work it's doing in this analysis?
Okay. In the what we actually do in the end is that we want to do look at the physics, philosophy of physics, and history of philosophy and sociology of physics language studies on the comparison between astrophysics and high energy physics. And some would say, well, these are 2 different research fields, and they have used different styles. So one uses observation, the other one uses laboratory experiments, for example. This is the classical 6 styles from Crombie and hacking. That's, I think, how we came up, or I came up with this link to the styles. And then more and more, I see these other type of links that I tried to mention in terms of the theoretical links of, because the other surprising thing to me, the whole theory behind these language models also is basically the same links that Fleck goes back to, like Gestalt psychology, and this idea that Wittgenstein, Hacking mentions Wittgenstein too, this idea that words have meanings in the context, or the meaning of a word is the company keeps, etc. These type of distributional hypothesis, it's also called in distributional linguistics.
I can do a question myself.
Sure.
Very interesting, thank you. I have a curiosity. So we know that actually papers are very complex artifacts. There's text, but there's figures, equations. I think there are so many equations in this kind of papers. So I was wondering how this kind of non-textual material is digested by the model. So because I assume that you download something like the Latin version of the text and then you have to process it. So I was wondering, these kind of features, how are they processed?
So my model was very picky and it just didn't like all of these. No, but what I want to say is that, yeah, exactly. I downloaded the LaTeX files because these were the ones I could parse the best. And I used inline formulas. I let them the way they are. But many several lines of formulas, I just collapsed them into some word like formula or some arbitrary, like artificial word, just to say that my model knows there's something there and I don't look at it later, but it's just because otherwise each of these token, like symbols inside of these formulas might be used as one token by the model, which would have polluted my training, and etc. But so we are not using, or I'm not using this information so far, but this was a pragmatic way for me to deal with it.
Yeah. Thank you. Any other questions? Or, yeah, please. You have to jump the chairs.
Yeah, thanks for the talk. I have a question about what you can do with these models, mostly the topic modeling and the classifiers. I'm thinking of using them to make a classifier myself, and I was wondering, is it already clear for what kind of things they outperform like cheaper classifiers, like traditional machine learning models, and the same topic model?
Thank you. I haven't worked myself too much with this, but I think there are studies that show that bird topic, for example, is a very dominant approach for topic modeling using BERT. And there's a whole library on for Python. There's a module for BERT topic, and there's libraries also within the Hugging Face pipelines for sentence transformers and stuff like that. So you would want to look there. And I think these papers at least claim that they have superior performance to classical topic modelings. Luca might want to say something about it because he also said that he is experimenting with this now and he finds that these topics are very meaningful in his research. My colleague is also doing the same right now and he finds they are very meaningful. What someone earlier mentioned also that language models can help us interpret topics, even if they're not coming from the topic models, but just to interpret the text belonging to a topic. I've made some little experiments in the context of another workshop series, very similar one by Jochen Gläser in Berlin that just started, and I'm doing some little experiments on using GPT-4, just zero-shot classification stuff on scientific paragraphs, and it works very well, I find. But I've just started, so I think it's very promising. Actually, I cannot tell you exactly. I'm not aware of a survey or anything that compares it, but it's very promising, I would say.
Okay, thank you very much. We have room for very, very short questions. You have a follow-up.
So, how did you choose the original model? Like, why did you use BERT and not SciBERT, for example? And do you have any idea of how it influences the results?
Cybird or BioBird are models that are also trained on scientific texts, and Cybird and BioBird, to my knowledge, are trained mostly on PubMed type of text, and that's the domain of biomedicine. So because I wanted to have a model that whose semantic space context is as closely as possible to my context of analysis, which is astrophysics and high energy physics, I wanted only this type of additional training to it. But I did use the BERT pre-trained model from Google because they trained it on Wikipedia and the book corpus, which is still it's big, but their corpus is as big as mine actually together. But they trained it for several more rounds, etc. And I think the thing is, for me, since I only use it with one laptop, etc., I had no time to make my model learn English in the first place. So I just wanted a model that has some text, which is not too polluting for me. And I thought Wikipedia and the book might be okay-ish. And Cybird, and I think Cybird is one version of Cybird is not using the pre-trained weights from Google, but BioBird is for sure. And there are all these experiments, yeah. But I have not done a full-scale evaluation because also I don't have an evaluation. Other people train these models with a downstream application like named entity recognition, etc. And then they have annotated data which they can use to evaluate this model against each other. I don't have that so far, so I can't use any of these type of typical types of evaluations. But I saw it in cases, for example, with the Planck case, I clustered the Planck with the Google plane model and with my model, and the clusters make much more sense and they're much more separated. So it shows me that it does some work that I want. Yeah. Thanks.